Hey guys, it's Den. Today I'm going to be talking about frequency distributions, which are also sometimes called frequency tables. They look something like what you see here, where you have some sort of interval, as in like ranges here, and you'll sometimes see frequencies, cumulative frequencies, relative frequencies, and cumulative relative frequencies. And I'm going to go over what each of these columns mean, as well as how to calculate the numbers in them. And I'm also going to try to give you some tips on like what columns you use to answer what type of questions. Because one of the hardest parts of stats, in my opinion, is figuring out what the question is asking for, like what it's asking you to find. Because there's a lot of terminology in stats, a lot of different ways of saying the same thing. So it can be kind of hard to figure out, what the question's asking. So I'm going to hopefully try to clear that up for you guys. So basically, in a frequency distribution, you're probably going to have some intervals here, which are also just ranges. So if you're not familiar with this like format of writing ranges, it's basically just saying some number x, this could be any number, but some number x is between 0 and 10. And this is including 10. That's what the less than or equal to here means. So like this is not including 0, but including 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the second range here is x is between 10 and 20, not including 10, including 20. So that's, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And the reason I'm specifying that is just to make it like perfectly clear because, if like, let's say our data had a 10, if we just had a 10, which range would it go into? Well, it's going to go into the first one because this is including 10 and this one's not including 10. Because this doesn't have the less than or equal to. The rest of this video, I'm probably going to be just saying, between 0 and 10, between 10 and 20. And we're just gonna say it's understood, that like when I say between 0 and 10, I'm counting 10 as in that range. Now what a frequency distribution does is we take some set of numbers, like just a bunch of numbers, and we count how many times they fall between each range. So here I have 10 random numbers. I just type these up randomly and we can make a frequency distribution out of them. Now I'm going to focus on frequency and cumulative frequency first because those ones are a little easier. Not that the relative frequencies are hard, but these ones are really not that bad. And once you get them, you'll be able to get the relative frequencies easier. So starting off with the frequency column. Frequency is just counting how many times numbers in our data here, so in this row, fall into each range. What we're going to do is, and I know not every single homework question is going to be like this. Not every question is giving you a set of numbers like this, and then you're going through and counting, oh, there's this many between 0 and 10, this many between 10 and 20. But I'm just showing you this right off the bat because this is a good way to understand what a frequency distribution is doing, and using that knowledge you should be able to answer most questions about it, even if they're not like giving you numbers and telling you to count. So basically to get frequency when we're given a set of numbers like this, so we're going to look at the first range here between 0 and 10. So I'm going to go through, so 5, that's between 0 and 10, so that's 1, 8 is, 9 is, 6 is, and also 10 is, because remember we're doing between 0 and 10 but counting 10, so 10 falls in this range. It falls in this range, not this one. So that means a frequency for the first row, 0 to 10, is 5, because there are 5 numbers in between 0 and 10. Let's do between 10 and 20 next. So we have 11, we have 11 again, and we have 14. Our frequency is just going to be 3 for the second row. And then hopefully you see where this is going. If you want, you can always pause the video to try to figure it out for yourself. I think that can be helpful, but I know most people don't. But, go for it if you want to. So what's going to be our frequency for the third one? Well, we have 21 and 25, and those are our last two numbers. So our last frequency is just going to be 2. So that's it. That's the frequency column. So whenever you see a frequency column, that's just saying how many numbers are between each range. So when you get questions asking you like, what's the number of observations between 0 and 10? Your answer would be 5. Cumulative frequency works a little bit differently. Where the frequency column is saying how many is in this range, how many are in the range 10 to 20, that's 3. Instead of saying that, it's saying how many are in this range or less. So it might just be easier to show you actually. The cumulative frequency for the first row, this is just always going to be the same as the frequency column. Cumulative frequency in the first is always going to be the same because what it's asking is how many numbers in our data down here are 10 or less. And that's the same thing as basically between 0 and 10. Because, we don't have any numbers that are, in a different range. This is the lowest range. So this is just going to be 5. And that's just a tip. The first number in the cumulative frequency column is always going to be the same as the first number in the frequency column. Now the second row is where things get a little different. Well, the second row for cumulative frequency is asking how many numbers are 20 or less. So it's not just how many are between 10 or 20, it's how many are 20 or less. So that includes all the ones in the row above it. So how do we get that number? Well, that number is just how many are between 10 and 20, so that's just 3, plus all the ones above it. In this case, that's just 5, because, and we can verify that here. See how many numbers here in this row right here are 20 or less. Well, 5, 11, 8, 9, 6, 11, 10, 14, that's 8 numbers. 5 plus 3 is 8. So our cumulative frequency for the second row is just 8. So cumulative frequency, basically what you do is you just take what row you're in and add that number to all the numbers above it. Third row, you can pause again, try to figure it out for yourself. But what the third row is asking for is it's asking for how many numbers are 30 or less. And we can get that by just doing 2 plus 3 plus 5, which just gives us 10. And you can also see this is just 8. This is just 8 plus 2. Just do one big plus right there. It's just 8 plus 2. But that's how you get cumulative frequency. So cumulative frequency, again, and I know I'm going to probably sound very repetitive, but trust me, this is an important point to get across. Cumulative frequency is asking for this range or less. The range of the row it's in or less. So again, cumulative frequency in the first column is asking for 10. Basically, it's asking for 10 or less, which is just 5. Then it's asking for 20 or less, which is 3 plus 5, which is 8. Then it's asking for 30 or less, which is equal to 2 plus 3 plus 5, which is 10. One pretty important thing to note is that this number here, your last number in the cumulative frequency column, this is going to be the total. That was a terrible A. I'm sorry, I can't really write well with a mouse. This is going to be your total number of numbers. Like you see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. And you'll see that's also the same as just adding all of these, which, that's how we got the 10. But you'll see these numbers are the same. So basically, you can get the total amount of numbers you have either by adding all the frequency column together or by just looking at the last number in the cumulative frequency, which is the same thing as adding all the frequencies together. The reason I'm saying this, though, is because there are some questions they don't tell you how many numbers there were in total. But what they give you is like the cumulative frequency column. So you can see the last number in it is like 100. And then you can be like, there were 100 numbers. And trust me, this is going to help with relative frequencies. You have to know the total number of numbers in order to find the relative frequencies. Okay, so real quick, guys, I'm going to do an exercise with you. Now, this is a question I've seen on the Stat 350 homework, so it's something you should probably know how to do, and that's working your way backwards, getting a frequency from a cumulative frequency. So now, well, these numbers down here aren't relevant, so we can just ignore those, but I made up some numbers here, which is why they're also just handwritten in, which I know my handwriting is not great, especially on a computer, but we're going to work with it. How do we get the frequencies if all we have are cumulative frequencies? Well, we know to get cumulative frequencies, and I'm going to go back here, we just add. So basically, we had a 5 in the first column because it's always the same in the first. Then how did we get from 5 to 8? Well, we added 3. How did we get from 8 to 10? Well, we added 2. See, now I challenge you to pause it here and try to figure out what the numbers are here, but I'm just going to basically give the answers here because I can't wait for feedback. So remember, the first row is always going to be the same with the cumulative and normal ones. So like frequency, it's just going to be 2. They're always going to be the same. Now, what is this number going to be? Well, we know that the cumulative frequency for row 2 is 6. This tells us that 6 of our numbers are 20 or less. How did we get from 2 to 6? Well, we added 4. 2 plus 4 is 6. And also, the way I think about it generally is just 6 minus 2 is 4. So our frequency here is just 4. So what about our third row? Our cumulative frequency is 13. How did we get from 6 to 13? Well, that's 13 minus 6, which is just 7. And there we go. We did it. So to get from cumulative frequency to frequency, you subtract. As in, how did we get this number in the second row? Well, we take 6 minus 2. How do we get this number in the third one? Well, we take 13 minus 6. But to get from frequency to cumulative frequency, we add. How do we get this number? Well, that's 2 plus 4. How do we get this number? Well, that's 7 plus 6. Or 2 plus 4 plus 7. Same thing. Okay, we got that down. Now we're going to move on to relative frequencies. When you see relative frequencies, or just when you see the word relative, what I want you to think of is decimals or proportions. I mean, they're the same thing. Basically, it's going to be telling us the exact same information, but instead of number of observations, like frequency right here, this is telling us there are 5 numbers in between 0 and 10. What relative frequencies are going to tell us is the proportion of numbers between a range. How do we get relative frequencies? And maybe if I show you, it'll start to make more sense. So basically, a relative frequency is just the number. It's just going to be the number of numbers in a range divided by the total amount of numbers. So I'm going to write this out real quick. This is the relative frequency of a row. This is equal to the frequency in a row, and that's going to be divided by your total number of observations. If we go back to this, to find our relative frequency for the first row, to find this relative frequency, what I'm going to do is I'm going to look at the frequency in the first row, which is 5. So for our first row, I'm going to have 5 divided by our total number of observations, which is, the last number in the cumulative frequency column, or again, if we added them all together, 5 plus 3 plus 2, that's 10. We're going to divide it by our total, which is 10. So I'm going to divide that by 10, which is equal to 0.5. And I picked really easy numbers because I specifically wrote 10 numbers intentionally just so division is really easy here and I can do it in my head. It's not always going to be that nice though. But yeah, this is our relative frequency for the first row. Our relative frequency is just, let me get the font size right. It's just 0.5. That's a little big. And what this means is that 50%, so the 0.5 means 50%. It's a proportion which works as a percentage. So basically if you multiply a decimal by, you probably get this, but just in case, you multiply a decimal by 100, that gives you a percentage. So 0.5 times 100 is 50. So 50% of our numbers, 50% of these numbers, half of these numbers, are between 0 and 10. And we know that's true because we have 5 numbers out of 10. 5 is half of 10. So yeah, half of our numbers are between 0 and 10. That's what relative frequency is. Instead of an exact count, like there is exactly 5 numbers between 0 and 10, it's saying that half the numbers are between 0 and 10. So let's, instead of me just repeating it over and over again, let's do it again for the next one. So how do we find the relative frequency for between 10 and 20? Well, we're just going equals 3. We're going to take the frequency in our, and see, this isn't the best way to write the formula because, it changes. There's more official ways to write it, but I'm trying to write it in a way that's easy to understand, and I hope this is easy to understand. It's basically whichever row you're looking at. So like if it's the first row, use the first row's frequency. If you're looking for the second row, use the second row's frequency. So we're looking for the second row, so we're going to do 3 divided by our total, which is still 10, which just gives us 0.3. And that's it. So that's telling us that 30% of our numbers are between 10 and 20. And then lastly, our relative frequency for the last one is just going to be 2. It's going to be 2, our frequency for the third column, divided by our total, which is 10. It's just going to be 0.2. And there you go. That's how you find relative frequency. But yeah, so see that what this is telling us is that 50% of our numbers are between 0 and 10, 30% are between 10 and 20, and 20% are between 20 and 30. That's what relative frequency tells you. And I know I'm probably being very repetitive, but it's important that you get this stuff down, so I just really want to make sure you get it in your head. One important thing to note about the relative frequency column is that one way to check that you did it right is that if you add all of these together, it's going to equal 1. It's always going to equal 1. You're always going to have to account for every single number in the data. So 100% of the numbers are 1. Now we're moving on to cumulative relative frequency. So this is basically the culmination of everything we've been learning. Everything we've learned up to this point, it's been leading to this moment. It's really long, but actually it shouldn't be that bad, because the thing is, we now know what cumulative means. We know that cumulative is like adding, basically. To get from 5 to 8, we just had to do 5 plus 3 to get from 8 to 10, 8 plus 2. Cumulative just means we're going to be adding. And we know that relative means decimals or proportions. When you combine cumulative and relative, what that means is we're just going to be adding decimals. We're going to be adding the relative frequency column together. So the first row, so very similar to how frequency and cumulative frequency are related. The first rows are the same. Well, it's the same here. Cumulative relative frequency, the first row is the same as the first row in the relative frequency. So it's going to be 0.5. And I know some 2Ds that have come into my session have been confused about wait, why isn't this 5? Isn't it the same as the first row? Well, you have to pair them together, basically. If they have a relative, they go together. If they don't have a relative, they go together. I don't know if that made sense, actually, now that I'm saying it. Basically, these two go together, and these two will go together. So, 0.5 is the first one. That's basically asking what proportion of the numbers are 10 or less. Well, that's just 0.5. It's the same as what proportion are between 0 and 10. Then we get to the second row. What proportion of our numbers are 20 or less? We're doing the or less again. Well, we know that 0.3 are between 10 and 20, and 0.5 are between 10 and 20. So, that 0.5 plus 0.3, 0.8. So 80% of our numbers are 20 or less. So what percentage of our numbers are 30, or what proportion of our numbers are 30 or less? That's going to be 0.2 plus 0.3 plus 0.5, which is also the same thing as just 0.2 plus 0.8, which is just going to be 1. I accidentally hit a 2 as well. This is a little hint. The last number in your cumulative relative frequency column is always going to be 1. Because, again, 100%. This is basically asking, this one right here is saying what percentage of the numbers are 30 or less. Well, if you look at these numbers, every single one of these numbers is 30 or less. That's 100% of the numbers. If you have the cumulative frequency column, you can find cumulative relative frequency without having to do the adding of this column right here, the relative frequency. Because see, to get it, I did the whole 0.5. Well, this is the same, then 0.5 plus 0.3, 0.8 plus 0.2. Well, you'll see that this is actually, these numbers are the same thing as just taking each number in the cumulative frequency column and dividing by the last number in the cumulative frequency column, which is our total. So you see the first number is 0.5, which is 5 divided by 10. Well, the second number is 8 divided by 10, which is 0.8. And you'll see the last number, 1, well, that's just 10 divided by 10, which is 1. If you have this column right here, you can actually get this. You can get these numbers without having to do the adding. Just once again, to make it clear, you can get 0.8 by either doing 0.5 plus 0.3, or you could take 8 divided by 10, the total. And that'll give you the same number. Either one will give you the same number. Okay, so we did it. We just went over the 4 columns in the frequency distribution. We went over frequency, which is the number in each range. We went over cumulative frequency, which is how many numbers are of observations or less, so 10 or less, 20 or less, 30 or less. Then we went over relative frequency, which is what proportion of the numbers are in a range. And then we did cumulative relative frequency, what proportion of numbers are 10 or less, 20 or less, 30 or less. Now, one tip to keep these straight in your head, because sometimes it can be hard, I already briefly touched on this, but basically, cumulative, when you see cumulative, that means you're going to be adding. As we go down on the cumulative list, we are adding. And now when you see the word relative, think decimals, which is the same thing as proportion, or proportions, which is the same thing as like percentages or fractions. They're all the same thing. But basically, when you see relative, you're going to be working with decimals. I have this little like four squared sort of thing right here. I can't remember what like the official name for it is, but basically it's just a way to help you figure out what question is asking for what column. Basically the question is going to be asking for something, one of these two things, and then it's going to ask for some specification, one of these two things. And depending on the combination of the two things, that tells you what column you're going to be looking at. If the question is asking you for a number of observations, and that's the way I've most commonly seen it worded, is number of observations. They're asking you for either the frequency column or the cumulative frequency column. Because remember, that's these two columns right here. These are the ones that are giving you a straight up number. These two over here are giving you proportions. These two are giving you straight up number of observations. So if they're asking you for a number of observations, you're going to be looking at one of these two columns. That at least gives you a 50-50. But then you can narrow it down even more. If they're asking you for a number of observations between two numbers, you're going to be looking at the frequency column. So going back here, that's this column right here. If they ask you for a number of observations, that's some number or less. The key word is or less. Then you're looking for a cumulative frequency. So that's the second column here. If they're asking you for a number of observations or less. Now, if they're asking you for a proportion, that's going to be one of the relative frequency columns. Again, remember, proportion, relative equals proportion. So that's going to be one of these two columns. If they ask you for a proportion between two numbers, that's going to be the relative frequency column, this column right here. If they ask you for the proportion of numbers that are some number or less, that's the cumulative relative frequency, which is our last column right here. And I realized I forgot to circle the or less. To put it into practice, if I were to ask you, what is the number of observations in this data? What's the number of observations between 20 and 30? Hopefully you'd be able to get it, but if not, that's okay. I asked you for number of observations between 20 and 30. So that should tell you we're looking at the frequency column. So between 20 and 30, frequency column, that's 2. 2 is the correct answer. There are two numbers between 20 and 30. If I asked you, what proportion of the numbers are 20 or less? And try to think about it. What number is that? Well, we know that I asked for a proportion and I asked for or less. So that's going to be a cumulative relative frequency. So I said, what proportion of the numbers are 20 or less? Well, that's going to be, this row or less. So 20 or less, the 20 is on this row. So it's going to be 0.8. I came up with this just randomly in one tutoring session. And I'm like, oh my goodness, this is genius. Hopefully it actually is. Hopefully it makes sense to you guys. If you think this is helpful, you can screenshot it and try to reference it when you're doing like homework or study for like an exam or something. Now I know this video is probably getting a little long, but what I wanted to go over next was just a brief thing about histograms, because basically histograms are the way you can visualize frequency distributions. And that's why on questions with frequency distributions, a lot of times you'll see histograms along with them. So I put our data into R, all our 10 numbers, and made a histogram of it. We have 3 squares here. Basically, one's between 0 and 10, one's between 10 and 20, one's between 20 and 30. And you'll see on the left is frequency. And see we have 5, 3, and 2. That matches up right here. So histograms are just a way of visualizing this table, specifically the frequency column. The two most common ones I see are frequency and also relative frequency, which I can show you right here. You'll see that it looks basically identical. Like it's going to be the exact same shape, except now you'll see instead of frequency on the y-axis, it's density. This is just a relative frequencies plotted. It's like you'll see the first bar between 0 and 10, that's 0.5. 0.3 is the second one, 0.2 is the third one. So sometimes on the homework you'll see them with the relative frequencies. So like if you saw this histogram right here, sometimes they only give you the histogram, they don't give you the table. So like if they gave you this histogram and said what proportion of the data is between 10 and 20, well, you could look at this and be like, okay, this bar right here is between 10 and 20, and that's 0.3. So the answer is 0.3. Now if they asked you like what proportion of the data is 10 or greater, this isn't actually something we've trained for, so I'm glad I thought of this. 10 or greater. Well, we know 10's right here. We know that this bar, 10 to 20, that's greater than 10. We know that this bar over here is also more than 10. You know, any number in between 20 and 30 is going to be bigger than 10. So to get the proportion of the numbers that are greater than 10, we just add these two bars together. So this bar's 0.3, this bar's 0.2. So 0.5, 50% of our numbers are 10 or more. In histogram problems, whenever they ask you questions, try to figure out how many bars match the criteria, and then just add them together. That's how you can solve like 99% of histogram problems. Okay, so hopefully frequency distributions are making a little more sense now. If you have more questions about frequency distributions, about anything I talked about in this video, definitely leave that in the comments. I'll try to get back to you as soon as possible. If you have any questions about future topics or anything you want me to cover, maybe anything I missed out on here, or just any, stats topics you want, leave that in the comment section as well, and I will probably make a video about it. I think that's about it. I'll see you guys.